Okay, have your periodic table handy because I'm going to talk about charges and group numbers and stuff like that. Okay, so you have your periodic table. You should know that most elements are metals, right? So, like the majority over here are all classified as metals. The only one that's not is hydrogen, that's a non-metal. And then over here, just this little corner right here are the only ones that are non-metals. And remember, you have that little staircase right here in the middle. You can find other periodic tables that have that. That little staircase separates and the metals from the non-metals. And those elements that are along that little zigzag line are the semi-metals. Again, you should know that already. Okay, so as far as group numbers, the main elements are the ones that are in groups 1, 2, not the middle, skip that. And then we've got 3, 4, 5, 6, 7, and 8. So those are the main elements, and those are the ones that are going to get charges that they're always going to have the same charges. And I'm going to talk about those in a minute. Groups 1, 2, and 3 are for sure always going to be metals that lose electrons and become positive charged. And then groups 5, 6, and 7 are always going to be non-metals that gain electron and become negatively charged. Remember that group 8, those are called the noble gases, and they're perfectly stable with full energy levels, and so they do not gain or lose electrons. So let me show you all that information right here. So go ahead and pause and copy that down. It says how groups 1, 2, and 3 have are metals, and they always lose electrons and become positive. So I've written down how group 1 is always going to be +1, group 2 is always going to be +2, group 3 is always going to be +3. Groups 5, 6, and 7 are nonmetals. They're always going to gain electrons and become negative. So group 5 is always going to be -3, group 6 is always going to be -2, and group 7 is always going to be -1. The group 8 elements don't lose or gain electrons because they're noble gases, they're stable, they have full energy levels. And the reason we don't look at the middle elements is because they're transition metals and they have varying charges. So in this video, I'm going to be referring to these problems, 1J, C, H, D, and number 2. Okay? So based on this information, let's go ahead and start talking about some of these problems. I'm going to start with 1J. So if we look at J, it says, which of the following can be classified as an ionic compound? Okay, so what you need to know to answer that question is, looking at the periodic table, again, we got metals, we got non-metals. It's very important to note that if a metal reacts with a non-metal, it's going to be ionic. So the farther away they are from each other on the periodic table, they're going to be ionic. If they are close to each other over here, they are going to be covalent. So non-metals are going to form covalent bonds, and a metal with a non-metal are going to form ionic bonds, and metal will form metallic bonds. Okay, so I'll have you write that down. Okay, so there's that. So ionic is metal and a non-metal, covalent is non-metal and non-metal, metallic is metal and metal. So you need to remember that. So here's one thing though, like non-metals are close to each other on the periodic table. If you have a metal and a non-metal, they're on like kind of opposite sides of the periodic table. So that's what's going to help you answer this question. Okay, so again, I go back to letter J, and the options are argon, calcium carbonate, water, sulfur hexafluoride, and oxygen gas. Okay, so how do I pick the right one? Argon cannot be ionic because it's just one element. Argon is in group 8. Just an element from group 8, not going to be ionic. Letter C, water, H2O. H and O are both nonmetals. What do we say? Non-metal. Non-metal is covalent, so that's not going to be ionic. Sulfur hexafluoride. Sulfur and fluorine are both also nonmetals. That's going to be covalent. And then oxygen gas, as we talked about earlier, it's just O2, so it's two oxygens bonded together. Oxygen is nonmetal, so they are covalent. That's a covalent molecule. The only option is calcium carbide. They're farthest away from each other on the periodic table. Calcium's positive. Carbon's in group 4. When they bond together, they form like a lattice structure. This is the only one that can be ionic. So the answer to letter J is letter B. Okay, I'm going to go to letter C. Letter C, you need to know charges there. Kind of what I was talking about, the periodic table, because you need to know what copper 1 phosphide looks like. So you should know that copper is Cu. You can find that on the periodic table. Phosphide is just phosphorus. Okay? Well, remember what I told you about charges? Because phosphorus is in group 5, it is going to get a -3 charge. So you should know that. Elements in group 5 gain 3 electrons. They get a -3 charge. So if I have copper, and see this Roman numeral 1, that is the charge of copper. That tells me the charge of copper. Copper is in the middle. Remember what I said about transition metals? You can't tell what their charge is because they can have different charges. They have to tell you. So that's what that Roman numeral is telling you. It's telling you that copper's charge is +1, always positive. So metals are always going to be positive. Remember that. Metals are always going to be positive. So here you go. Copper's +1, phosphorus is -3. The charges have to cancel. So you're going to have to use 3 coppers to cancel out the phosphorus. You need 3 coppers to cancel out 1 phosphorus. So this is what it looks like. Cu3P. Now, the question, now that we did all that, the question is asking for the molar mass. So what do? We have to add up 3 coppers. So 3 multiplied by 64. Remember, that's the decimal number from the periodic table. And you're going to add it to the 1 phosphorus, which is 31. Add them up, and you get 223. So when I looked at the answers, the only closest one, and remember, I like to round. So if your teacher doesn't round, but I mean, you can see that's the only answer that's close. 221.61. So that's it. Okay? So that's letter C. Let's go to letter H. On letter H, okay, this one deals with what are called polyatomic ions. So you need to know, you should know which polyatomic ions your teacher has asked you to memorize or know. So like, for example, NO2 is called nitrite. And the charge of that is -1. You're supposed to know that. So here I have NO2 with a -1 charge. Notice that there's 2 of them. Since you're going to need 2 of them, you need to find out, okay, so if I need 2 -1s, what's the charge of PD? Okay, again, what's PD? PD is a transition metal. It's in the middle. You can't tell what it is. But since you know that this is -1 and there's 2 of them, then PD, in order to cancel, it has to be +2, right? They have to add up. That makes sense? So 1 PD is going to be +2. 2 of these NO2s are going to be -2, right? Add them up, both of them together. They cancel out. And that's how you know that you are going to need that the charge of PD is +2. So that's the answer there. Okay, there's H. Letter D. Okay, let's go to letter D now. Okay, this is going back to this polyatomics. There's a reason why I'm doing these the order that I'm doing it. The polyatomics, you are supposed to know certain polyatomics. I'm sure your teacher has told you that there are certain polyatomics you need to know. For example, C2H3O2 is called the acetate ion, and CO3 is called the carbonate ion. And when these ions are bonded to hydrogen, they form acids. So, what is carbonic acid? Carbonic acid is going to be the carbonate ion bonded to hydrogen. There you go. So it's kind of easy if you know your polyatomic ions. And if you don't know your polyatomic ions, you're going to need to make some flashcards or something. All right, next. The last one we're going to do here is going to be number 2. Number 2 kind of wraps up all of the stuff that we just talked about. So look, write the chemical formula or the proper chemical name on the line provided. So on letter A, they give you the name, so you have to give the formula. And on letters B and C, they give you the formula, so you have to give the names. Okay, so going back to everything that we just talked about. Look, copper is a transition metal. They have to tell you the charge in a Roman numeral. That's why it's +2, always positive. Sulfate is a polyatomic ion that you're probably supposed to know. The charge of it is -2. You have to know that also. So sulfate is SO4 and the charge is -2. So look at the charges. +2 -2. What happens? They cancel out to 0. So you only need 1 copper and 1 sulfate. This is the formula for copper to sulfate. But you have to know the charges. You don't know the charges, you're not going to be able to do that. Okay, the next one. S2Cl2. Well, if you look at the periodic table, S and Cl are both nonmetals. See how they're on the non-metal corner of the periodic table? They're really close to each other right there, S and Cl. Okay, so since they're both nonmetals, they are covalently bonded. So right here, look what I wrote right here, covalent. They're covalent. So you have to use prefixes. So you, again, should know that for covalent compounds, you have to use prefixes. Mono, di, tri, tetra, etc. I'm going to have you write those down. Okay. So there you go, prefixes for covalent compounds. Those are the first 6. You probably don't have to do much more than that. Again, you would know better depending on what your teachers told you. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa. So for this particular problem, all we have to know is 2 because look, there's 2 S's and 2 chlorines. So we would name that as disulfur dichloride. 2 sulfurs and 2 chlorines. And the last one, the difference between this letter B and letter C is that letter C is ionic. How do I know that? Because Mg is a metal, for one, and then HCO3 is a polyatomic. Notice that I've wrote that there, polyatomic. Again, probably one of the polyatomics you're supposed to know. The charge is -1. Hydrogen carbonate is the name of this polyatomic. The charge is -1. Magnesium is Mg, and it's in group 2. See, right there, group 2. And remember what I told you earlier, group 2 elements get a +2 charge. So, since Mg is +2 and hydrogen carbonate is -1, you're going to need 2 of these to cancel out the charge of one of those. So this is what it, I guess that doesn't even matter. All you need to know is the name. Anyways, I explained more than I had to there, but at least now you know. So what you do need to know is that since it's ionic, you do not use these prefixes, the mono, di, tri, tetra. You just say the name of this cation, the positive ion, and the name of the anion. That's it. So the name of this is simply magnesium hydrogen carbonate. That's it.